MapleSim allows you to create custom components so you can model specific physical behavior that may not be included in the comprehensive collection of default components. To create a custom component, we'll use the built-in custom component template, which allows us to implement our mathematical equations directly without having to do any sort of manipulation or programming. We'll select the attachment icon and use the custom component template. The template opens within a Maple worksheet, and here we're able to specify our mathematical equations in a direct manner. We'll use the example here of a custom DC motor. We'll change our name to custom DC, and in the next section we have the ability to implement our mathematical equations, our parameters, and our initial conditions of that component. Here you can see they've already been pre-populated for a DC motor, so we can leave them as is. In the next section we can specify the component ports for our custom component. MapleSim is an acausal modeling environment, so you can assign a combination of input and output variables to a single port. We'll click Clear All Ports to begin adding ports as we would for any custom component. You can specify the position of your port, and here we'll create a negative pin for our DC motor. The port type will be a negative pin, the name has been pre-populated, and we have drop-down menus for voltage and current, which are pre-populated based on the variables we specified above. We'll select our negative voltage and select our current, while making that current negative for the negative pin. In a similar fashion, we'll create the positive pin and a rotational flange. Once you've created your component ports, you're able to generate your MapleSim component, and our component will be brought into the MapleSim workspace. On the left, under Project tab, we'll see our custom component, which will stay with our model as part of our project folder. We can drag and drop this component as we would use any other component in the MapleSim workspace. For example, we'll connect this component to a step voltage and an inertia component with some rotational damping. A quick simulation shows the behavior.